discuss today about the sustainability drives in the industry, and definitely we should have some conclusion coming out of this panel discussion. So I'll start with a few questions on this, or few discussions, starting with the panel. And see, actually, I know that Thailand is one of the countries who has decided to achieve net zero by 2050. And most of the companies who are there in Thailand, they are seriously working towards it. Government also taking few larger steps towards it, and they are coming out with the new policies. Am I right? Indeed. So to start with, I would like to start with Verma ji. What is your insight on this, and how you are pursuing sustainability? What are the policies that you bring in?
Thank you, Anant, and good afternoon, everyone. Thank you for giving opportunity to part of this panel discussion. I will just take 2 minutes to do the context setting, which you are talking about sustainability. And we all of us know that last couple of years, for example, before 2010 and 2015, people were more talking about sustainability because of compliance only, because government wants a sustainability report, because regulation wants something, so you are forced to do certain things. And we were trying to, highlight even small things and giving everything like green and everything. But in last 5-10 years, we have realized that if we will not move actually on a sustainability direction, it will be on tick box exercising. Steel industry was also facing same thing. People were started to doing the things. The first challenges which came into traditional steel and other steel plant is that, for example, across the globe, almost 70% of steel production is through blast furnace route or iron ore route, which emits carbon dioxide in a very heavily. For example, to produce 1 ton of steel, the emission of CO2 is 2.5 ton steel through a blast furnace route. We from India know Tata Steel, JSW, even in China, most of the steel producer integrated plants are through that steel route only, and that is why the emission is very high, and it is 70%. Only few steel plants were using scrap-based or other technology where the emission was less or something. And because I worked for more than 25 years or something in Tata Steel and other cases, we realized the biggest thing is the cost of production. If you use a traditional process of iron route, your cost of production is very less, and people have to take advantage of it. But recently we realized that if we will not do certain kind of interventions, we will be there only. In fact, I personally say, when I was discussing with CEO of Tata Steel for one kind of a green steel plant, I am fortunate that he said that even your cost of production is high, please try to experiment it, because if we will not do, who else will be going to do? So last 5 years, there is a significant change in steel industry, because the other route which we are talking about is having CO2 emission almost 70% less. The company which I am representing is going to set up a plant in Rayong, where the CO2 reduction will be more than 70-80% compared to a conventional technology. Now, there are two approaches. One approach purely coming from raw material side, how I use raw material which is less CO2 emission. And second thing is about energy, which is a very heavy electricity consuming industry, which is related to scope 2G emission, where the total is depend on the renewable energy. So the plant which we are going to operate in Thailand is 100% renewable energy based on solar or something, and you will be surprised to know the kind of electricity we are talking about is more than 500 megawatt capacity. So we are going to have a big setup with partnership with many renewable energy companies in Thailand to make our scope 2 emission zero. For scope 1 emission, we are going to have our own plant of iron ore felicitation in Oman, where we will import something. We will use combination of iron ore and the combination of scrap to make our total emission less. The biggest thing which I want to say that which we have realized that we have to be more pragmatic and practical. Nowadays, people are talking about hydrogen uses a lot. And I'm sure that it is going to take time. It is going to take at least 5 years to establish the total hydrogen usage in steel industries at a optimum level. Because if you are not commercially sustainable, then you cannot be sustain your progress. So what we believe is that whatever you do, it has to be climate friendly, but at the same time, it should be commercially sustainable. Thank you.
Samrat, I have one more question for you. One question for you, that is, when you are working towards the sustainability, you are handling a complete vertical who is taking Indorama towards sustainable future. So while making the policies and while implementing the sustainabilities, what are the challenges you face?
Okay, so sustainability is a very noble word. Everybody wants to be a part of it, but it comes at a cost. And it's something that we, as all industries are maturing, global warming is taking place, there is a lot of awareness and conscience, because of which big companies such as Indorama, Meranti, we have all embarked on our sustainability journey. We have set targets with SBTi or without SBTi, which is published on our websites. So if you go to our website, you'll see that, and it's a website which is constantly updated with all the ratings, etc. So we are on the forefront of doing whatever we can do. But it's the markets which need to kind of absorb it. So we are typically a B2B customer, a B2B company, right? We are not B2C. So our challenges are that if we are not able to go directly to the markets, going directly to a B2C kind of a environment, we come in contact with our customers who are B2C. So the challenge is the absorption of the extra cost to drive sustainability. From my experience, what I have seen is that sustainability normally is driven by two aspects. One is, of course, your own conscious belief that you would like to be a part of it, and you really need to provide the good for the environment and for the next generations. The second is regulations. So if there is a regulation, then definitely the markets start to absorb it. The brands, the companies who are B2C, they start pushing it because there is a regulation. Look at what happened in biofuels. Or let's say in Thailand. Thailand is a country where a lot of biofuels is produced. And now they're blending it for several years into your fuel. And it is being purchased and consumed. So that's how regulations have. So challenges, when I say challenges are there, yes, headwinds are always there in any industry, in any policy, but they all have to be absorbed through some way or the other. One is on organizations taking the first step forward, which we have already done. We have done a lot of decarbonization at our end in the last 4 to 5 years. And the second is now we are looking at markets to absorb it. So that's where I would put the challenge.
So way ahead, maybe 10, 15 years down the line, do you look at this drive as an opportunity?
So yes, there is an opportunity for my fellow panelists from other companies who are producing the services, the goods for us to be able to achieve our objectives. These are the opportunities which come about through technologies, new technology and new technology maturation. So right now, let's say we talk about carbon capture. So how do you want to decarbonize any kind of steam boiler or any such heat utility? So one of the things is it's going to emit. Whatever you burn, it's going to emit. So carbon capture is one thing, but is it reasonable? Not yet. So there is a maturation process which has to happen. Once you have carbon capture as a mature technology, I would not say technology, a usage of the technology and cost effective, then we will see more of it. So I think 10 to 15 years is too long, maybe 5 to 7 years, I'm hopeful before I retire, that we will see that maturity happen. We will see more regulations which will support this kind of exercises, this kind of initiatives. which will also give rise to more newer technologies. But that's, so I am very optimistic, to put it.
Tony, so when Samrat is talking about innovation and technologies, being very specific, we are talking about the steam generation in this panel. So how do you look at it? What are those technologies which are coming in steam generation, wherein the end customers who are using the boilers or who are generating the steam will get benefited and they can march towards the sustainability?
Right. So thanks, Anant, and it's a privilege to be on this panel and sharing this dice with these esteemed panelists. So a good question, and I think let me give some context before I get into the the question that you asked. So you spoke about steam generation. So if you look at steam as a utility, it has been the backbone of the industry for more than 3 centuries now. Okay, and I personally believe that it's going to remain that for some period of time, until unless someone comes out with another utility that is equally powerful as steam. And it's been a challenge so far because of the inherent qualities of steam, the high heat transfer rate, the latent heat. We are not yet able to find a replacement for it. Yeah. So having said that, steam generation today remains as a main consumer of industrial energy. And if you look at the numbers, 15 to 20% of the industrial energy use comes from steam generation. And when you generate steam, you consume fuel, and by doing so, you are actually a carbon emitter. Yeah. So there are a few ways to go about it, and the first step, according to me, would be looking at efficiency. How do we utilize technology to improve the efficiencies of existing steam boilers? It could be electrification. It could be moving to hydrogen powered boilers, as Mr. Verma also mentioned. It's still in the feasible study. It's more popular in the West than what we see today in India, in Southeast Asia. But I'm sure it'll catch up and we'll find ways to beat that. I think the second way is, how do we look at transiting to cleaner fuels, fuels that have lower carbon, and as I mentioned, hydrogen. And I think these two are very fundamental to do. But I think today the gap is customers don't really understand where they are at in terms of their energy consumption. So I would strongly recommend that every plant should do a thermal assessment of where they stand today, identify the gaps that exist in the boiler house in terms of the efficiencies, look at the gap that exists in the steam distribution, look at process optimization by way of right temperature controls, pressure controls, and then lastly, how do we utilize the heat back from condense and flash steam? And of course, when you do this, you understand where you stand today, you take these corrective actions, improve the efficiency of the plant. And the fourth element, which is very important, is sustaining this efficiency over a period of time. And how do we do that? By way of digital monitoring, the use of AI, which tells you, which direction your plant is headed to. And if there are any deviations from, from the norms that you set, you can immediately take a corrective action. So I think these are the, 3 or 4 things that I can think about as the, the right things, so the right steps to do as far as steam generation is concerned.
As we were talking about the measurement, monitoring, what do you think, how important to monitor all the parameters and how important it to get analyzed?
Yeah. So Anant, if you look at a plant that is monitoring its critical parameters, for example, boiler efficiency or the condensate recovery factor or the process temperature itself, we see that there is so much of variation. Yeah. A plant that has a monitoring system as against a plant that doesn't do monitoring system, we see that there is a gap of at least 10 to 15%. Yeah. So of course, digital monitoring the systems help a lot in terms of collecting the actual data. And when you are monitoring, you know that there is either you're going the right way or the wrong way, so that you can take a preventive action. And I think that's a gap that exists in the industry today. If you ask me what percentage of the customers monitors their boiler efficiency, probably 2%, 3%, And Lorenzo, my colleague here, we are all boiler manufacturers. So when we sell boilers to our customers, we say the efficiency is 94%, 95%. But if you do not point to the efficiency, there are losses that goes up and down, and which is dynamic, that causes the efficiency to come down. So when the efficiency comes down, you end up consuming more fuel than what is, required. So of course, there's a lot that monitoring can help, and will ensure that the efficiencies are sustained over the lifetime of the equipment.
In fact, I will add few points, Tony. I think it's a very important subject when we talk about decarbonization of a steam network or so. You don't need to go for any technology or something. It's a very common sense. We are not yet able to extract low-hanging fruits fully, like you say about efficiency, monitoring. There are basic things. Even temperature variation of steam or something. You can understand plus minus 30 degree, 40 degree is very common in process or something. Nobody is bothered about how we reduce the standard deviation. In our own body, our normal temperature should be 98.4 degree Fahrenheit. We know within 2-3 degree what is our condition. If our temperature goes 100, 102, you can't exist. So 2-3 degree variance in your own body can play your needle from here to there. But in a steam network, if you are talking about variation, high temperature variation, lot of steam leakages or something, there are many easy ways to control it. And I am sure there are 20-30% efficiency can be only improved just by monitoring and putting a good attention on the overall process network.
Indeed, rightly said. Yeah.
Actually, I was discussing yesterday with Lorenzo about what he does. What is their way of, way of doing the business. So first word, what he spoke was we set up biomass plants.
The only player here in the biomass file that to me is biomass plant, and biomass to produce steam is, let's say, the closest way to achieve let's say a 50% of net zero emission in the steam sectors. Because we do have other technologies. We do have, for example, carbon capture, as my colleague said, but carbon capture is still not ready to me, I think. Mainly in smaller plant, carbon capture needs like big investment. We need to develop that technology, but biomass plant, we had it since more than 15 years, and biomass can really help to make the steam production more sustainable in a really different way. I mean, biomass is coming, if you take it, I mean, if you can control really well the supply chain, it can really be a good substitute for fuel sources like gas or coal. But the pathways, I mean, we are doing the pathways in, for example, in Europe, there's a lot of policies and a mechanism like emission trading system or carbon tax that are helping the penetration of these different technologies that require higher investment cost, but at the end, this is the barrier, the capex. But once the plant is running, if you have done a good, let's say, study of the supply chain, a good study of the process, if your customer in the industry had some byproduct that can be utilized as fuel sources, this kind of technology can still be competitive and not only I would say in price things, but also as not only for compliance, but can also be a market advantages. Like my product is sustainable. For example, in Europe, the market is moving in this way. We had some customer that say, let's say it's a brewery that he produces beer, and he say, I want to do my product more sustainable. I do have a fuel biomass supply chain, and I want to switch my production of steam in a more sustainable way. He invests for the sustainable boiler with no incentive. He just he commit to the let's say sustainable goals, and now his product in the market have this added value that the others do not have. Like he can sell, let's say, most valuable product that are sustainable product. So there's a different way to tackle this market. There's different way to pass through sustainability, and like with biomass technologies, that is a well state-of-the-art technology, we are already doing this.
As you said, so in Europe, where you actually, which is your addressable market, there the biomass plants have been considered only for the sustainability or as a replacement to the fossil fuels, correct?
Yes, exactly. Of course, you can't replace all the plant with, let's say, with biomass plant, but if you, for some process, you need, if you will, like, is a pathway through the changing of the fuel. Some plants, some customer already do have some waste that they don't know that this waste could be, evaluated as a fuel, as a source. It's just waste for them. But doing some good design, doing some engineering of the plant, optimizing the consumption. In Europe, we are moving toward this. We are changing a lot of plants into these biomass technologies.
When we talk about a steam plant, definitely we must talk about water as well as one of the resource. And in the industry, when we generate steam, sometimes we don't get the condensate back, and most of the processes is like that. So how do industry manage to protect or to conserve water as a resource, which eventually part of sustainability as well?
Water, definitely a very important resource, and we all know that it is, in our ancient wisdom, we talk about 5 basic elements about Mother Earth, water, air, Akash, something like this. And water is very important. So for steel industry also, water consumption is being monitored very carefully, and a lot of cooling water tower and which we use. Now people are talking about zero liquid discharge or something. There are regulations. Again, here the same concept, I would say. Before going a technological revolution, first set your systems on a basic fundamental right. I have seen personally that there are a lot of wastage of water just like a blowdown. People are not controlling the quantity of water which is being blown out, assuming that, it has certain kind of a pollutant or something. No proper measurement, no proper chemical dosing or something. So the moment we do a dissecting of all those data related to how much water you are losing in evaporation, how much you are blowing down, easily 10-20% consumption can be easily reduced or something. Okay, and this is how you have to first set your things right, instead of trying to experiment certain new thing which is going to reduce your water consumption or something. Good part is that now digital technology is also helping a lot. In fact, I would like to give a very small example, because in a steel industry, apart as a utility consumption of a water or something, water is also dangerous as far as liquid metal is concerned. A few drop of water, if goes into a molten steel, it can lead to explosion. So in steel industry, we have electric arc furnace, and those furnaces are continuously cooled through a circulating water. Means you have copper panel and tube through which water is doing. Now the important challenge to us that it's not about water wastage or something. The moment, suppose there is a water leakage because of some tube get punctured, it is a dangerous situation in steel industry. How to early detect the water leakage? Not for consumption, but for a safety point of view. Now there are technology available. So for example, it's like a very cooking process. Steel is not a very this thing. So you are trying to melt iron ore and coke and something, and you are melting it. A lot of fumes are generated, and flue gases are going through your chimney, and you are controlling it. Now, earlier it was very difficult to detect water leakage. Only through physical camera or something you found there are certain things. You have to stop the furnace, you have to cool down, lot of. Now, in our flue gas detection system, there are laser detector. And those laser detector, while normally they measure carbon monoxide and carbon dioxide, nitrogen and NOx emission, it can also measure the water vapor or something. So now within few seconds, if my fume exhaust system is able to detect water vapors, it can alert the control operator that please stop the furnace, there are certain kind of water leakage. This is how we are trying to leverage the technology. And it is very good for these things. How proactively, because it's not about consumption, it is the ensuring safety of human being is also very important. So just to summarize two things, definitely we have to make our fundamental system correct related to blow down practices, zero water discharge, chemical dosing. It should be a systematic dosing. It should not be leave it to contractor that he will come and dose. I have seen a plant where contractor is every day dosing some kind of a chemical without seeing the water quality. It's a wastage of water or something. The moment you put a systematic control, you only do treatment, whatever is basic is required, you are able to control blow down, you can improve water consumption significantly.
So, Anand, if I can just add, one more point here. I think he's covered most of it. So, the point is, how do we look at, water as an important resource as far as steam generation is concerned? So, let me go one step back. So, if you look at the whole steam loop, the source of producing water, steam from the boiler is water. Now, the water can come from a DM plant, it can come from an RO plant. Some places where you don't have both, you use a water softener to, treat the water before it goes to the boiler. Now, there is a hidden cost beside the water cost, which is the chemical cost, the cost of treating water before it goes to the boiler. Now, as he rightly mentioned, the water that goes inside the boiler, most of it is evaporated. 2 to 3% of this actually is lost as blowdown loss. And we have to find ways how to optimize this blowdown loss, only doing a blowdown when the TDS is reached a particular level. The biggest saving opportunity here is not only the blowdown, but the steam that is generated from the boiler, it goes into the process, the steam transfers the latent heat and it becomes hot water, which we call as condensate. Now, if you walk around different plants, you will see that maybe 1 or 2% of the plants today, irrespective of where they're located, they have systems to recover the condensate back. Yeah? Condensate is pure water. It's got a lot of energy. And we should ensure that every drop of condensate comes back into your boiler house, into the system. That is a big saving opportunity, not in terms of water itself, but in terms of energy also, because you're carrying so much of energy back, and then to reduce your fuel consumption because your feed water temperature has now increased. There is a lot of focus now on improving the flash steam recovery, which was a very neglected subject in the past, because flash steam also has a good amount of energy that can be recycled back. So if you put the numbers together, 100% water is going into the boiler, 3% would be the blowdown, 97% going into the plant, of which 10% would actually become flash steam. So it's important to have systems in place to recover the condensate as well as flash steam back into the boiler house, which is probably the biggest opportunity for water and chemical savings. Yeah.
Rightly said, Tony. Actually, as I read through, the 55% of the energy is there in only flash steam. Though the volume is less than 15% of the energy which is there in the flash steam is almost 55% of that. And again, 2-3% blowdown is again an opportunity for the heat recovery, which add up into saving of energy cost.
Yes, I just want to add, Tony. So this flash steam in Europe, of course, being a colder continent, we have this flash steam in several of our units. And district heating, this is what we've used it for actually. We've put some coils, generated some hot water to kind of compensate. I'm not saying it entirely compensates the heating, let's say the domestic heating within the factory or within the offices, but it does. So that's we have. It's one of our initiatives in Indorama where we are trying to recover as much water. In fact, if you see our water parameters, we are doing marvelously well, and that kind of dwarfs our GHG, because GHG and energy reductions are definitely more challenging. And when we see our water savings, it gives us some respite. So, and to what Mr. Verma said, another point, another big blowdown which we have noticed, although we are not having huge cooling towers, but cooling tower blowdown is another area where we have tried to optimize by bringing in certain new technologies where we increase the cycle of concentration, which gives us some respite without really having putting in more dissolved solids in the water. So there are some new technologies available. I won't say they are new anymore. They are pretty traditional, but yeah, it's been properly articulated, properly applied, and monitored.
That means the integration of various technology in running a steam plant gives an additional benefit in energy conservation as well as creation of lesser greenhouse gases. And while considering the integration of new technologies coming in a steam plant, how do you look at it when it comes for a capital investment?
So capex is always an issue, especially in petrochemical industry nowadays. That's for the last year and a half or 2 years. So that's why in the beginning I mentioned that we did a lot of decarbonization on our own, as our own incentive, the last 5 years. And of course, it's become a little bit less now because of the situation in the petrochemical industry. If we look at capex, if I am the decider to budget out the capex, fine, I would do everything, the full 9 yards. But the thing is that what we have to look at is the return on investment, typically for any capex. Sustainability projects, the low-hanging fruits which give you return on investment in 2, 3, 4 years is all taken up. Now are the higher fruits. And where the return on investment goes to 6, 7, 8 years and more. So the way we are looking at it is, instead of taking a hit on our balance sheet, we try to look at energy as a service. So that's one way of kind of deleveraging. And we try to see that we don't spend, but we make an ecosystem around our sites where we buy the energy as a service continuously. That's the way we are looking at it. And in fact, we have already started implementing. We have a lot of sites. We have 117 sites. So all across the globe. So certain geographies where we find it kind of working, functional, and giving us good returns, and where we can absorb a little bit of extra OPEX, because obviously if somebody is going to give it to us, we try to implement it. Also, what it does is that it takes the monkey off our back in trying to maintain the utilities on our own. So it's like an outsource. So we outsource it, we get consistent, good quality utilities, and all the other aspects of it in trying to maintain it, other issues related to, let's say, manpower, etc., is all taken away. Even the regulations part, etc. So that's how we look at it.
I think I will just add one point what Samrat is saying. This is a very interesting dilemma in boardroom or in all the senior management discussion, because the sustainability officer is proposing certain capex where the IRR is not very good or something. CFO definitely need more than cost of capital or something, and this debate is always. So how do we address it? There are 2-3 ways to address this particular dilemma. Because we owe this planet for our future generation, we have to do certain thing, but not at the cost of, because you have to have your commercial sustainability also. So the 2-3 approach which follow, one approach is the carbon adjusted IRR. For example, there are projects where we know what is the cost of CO2 or something, $30 per ton, $40 per ton. We put into the system and say, my carbon adjusted IRR is so much or something, and despite I know that it is a low IRR, I am going to approve this project or something, because we are looking for future. Another way is that how much percentage of capex allocation. Suppose my organization has to spend 1,000 crore per annum. I decided 50 crore, I will not look for IRR, but I will allocate at least 50 crore every year to drive my decarbonization project or something. So there are ways and means through which you can keep on driving. In different part of geography, carbon CO2 cost is also different or something. So when I was in Singapore, and when Singapore first time started carbon CO2 tax, they started with $5 per ton of CO2 impact, which was a very minimum of something. But being a steel company, we were getting hit. We were getting hit almost $2 million per annum impact because of this or something. But at the same time, I appreciate the approach from government of Singapore. They say, we are introducing this tax, and in next 5 years, it is going to increase every year. So from $5, it will go to $10, $20, and today it is $30 or something. The idea is that please make your home correct. So if you feel that after 5 years it's going to hit you, please try to do certain kind of investment in your technology so that your heat is reduced or not. There are countries in Europe or something where CO2 impact is more than $150 per ton or something. But in those countries, government invest back this tax collection back to the industry in promoting user-friendly technology. In this part of this, we are not very habitual about carbon tax. Even $20 per ton of carbon tax or $30 tax paying or something. So somehow the overall standardization is required, that how we are going to have a good measurement of scope 1, scope 2, and scope 3, and this is how we have to address the whole concept.
Anant, yeah. Verma ji, I think I'd like to clarify again. So we are, of course, we don't want to steal the show here, but the thing is that carbon monetizing, I think that's what you mean. So if you save carbon, for example, I go to Forbes Marshall or to Lorenzo to put up a biomass-based plant. So I do save on carbon emissions, which I can trade.
Yeah.
Okay, so if I can monetize it to help me reduce my OPEX, that's one way of looking at it. The second way is internal carbon pricing. So if I am given a budget, as you said, $5 billion or something like that, which is, let's say, it's a carbon pricing, internal carbon pricing that I have, and I can use it against any kind of additional OPEX, that's another way to drive it.
Yes.
The third thing is on Europe. So we have a very large presence in Europe, and we take a hit out there on carbon emissions. So if it's more than 20 megawatts of installed capacity, as in terms of your energy requirements, whatever is over that, it's not a tax, it's an ETS, it's a trading system. So you are supposed to buy, using your dollars, euros, to buy the carbon credits to offset what you are generating more than 20 megawatts. So this brings me to the regulation part.
Yes.
If there's a regulation, the whole system, the whole supply chain, everybody kind of falls in line, adjusts, and then it gets passed on to the final market. So that's the point I was trying to make. Thank you so much.
Thank you.
So apart from, getting benefited to the CO2 credit, carbon credits, is there anything which is come from the government side as a policy, or some kind of incentives if you optimize your plant for the decarbonization? Is there anything that which comes from the government side?
No, so basically you bring down your energy consumption below 20 megawatts. So then you don't. So when you do that, so there is there's a second incentive. So let's say I put a high efficiency burner, and there's a $500,000 investment. I do get a subsidy of 30% in Europe to put that high efficiency burner. So there is a second incentive also there. So first is that, okay, because of regulation, you do what you need to do. But if you take a step towards decarbonization, we will support you. So those kind of things are there. Of course, they happen in more mature economies. Singapore would be one of them. Europe is another one. US, we can't talk about it now. But yes, so if there is a framework from a regulatory aspect, it can work. And that as a manufacturer, I'm sure Mr. Verma will also agree, as a manufacturer, we need some support. But if it has to be voluntary, we can go to a certain extent, whatever we can absorb. But then the balance has to be passed on.
And I will add a few additional points, Bhaskar. It is like this, like you said, different geography, different rule. I will give you a small example. Tata Steel is a big plant in United Kingdom, and they were struggling to decarbonize it. And after 5 years of deliberation and discussion, finally UK government is giving $500 million final assistance to decarbonize it. It's a big amount or something, okay? And similarly in Europe, Stegra is a big organization. They are investing more than $6.5 billion on decarbonization. But my belief is that, one time infusing money is good enough or something, but you have to sustain it. We have seen it's like a first way of learning from this, that European plant is not able to sustain it despite this government support or something. So you have to have a hybrid approach. Hybrid approach means you have to be practical. Don't just go with a flashy word that I have to decarbonize. Please try to see next 10 to 15 years how you are going to run this plant. It's like initially to fund this plant, you build it, and after 2-3 years, you again struggle it. It's a waste of money or something. So you have to be practical on those aspects.
Again, coming back to sustainability. So if you build it, you have to sustain it such a way that it will be running at full efficiency and give you the benefit. So to do that, again, Tony, how many times you come across an inquiry from your customer where the objective is increasing the efficiencies or reducing the carbon footprint?
Yeah. So it's a mix, Anant. So if you look at the corporate customers worldwide, most of these plants have an energy manager or a sustainability engineer, whose goal is to look at reducing the carbon footprint of the plant. So we see a lot of inquiries and these requirements coming in from corporate customers as compared to single owner based plants. Primarily because their goals are different. If you look at an owner based plant, his first priority is to get maximum production without paying too much focus on the energy consumption. And for a corporate, probably because they have a policy towards reducing the carbon footprint, probably they have insufficient funds to run those initiatives. It happens much faster and quicker there. So I think the important point here is, as both of them mentioned, it's the government policies which actually makes these initiatives go forward. And until and unless the government pushes this really hard, it's going to take some time to really see these things being implemented. And as you rightly mentioned, Samrat, we see a lot of these initiatives happening in some countries, South America, a lot of countries in the Europe, where the government is helping them, in terms of financing these projects and also incentivizing them when actually when they save the emissions every year. So it's a mix and match based on the kind of end user.
If also I can add, let's say reaching a net zero and reaching sustainability is a matter of policy. Policy help to penetrate it, but should also be seen, and in the past years way more, as market advantage. Because now, for example, there's a lot of rating score, like EcoVadis, like this big corporate that want to show that they're sustainable. And if I go through a supplier that have this high rating in sustainability, I can invest in that. They can invest to do their plant in a sustainable way, to have market advantage, and thus the customer also, my product can have more appeal to the customer. Also for steel factories and all of these high consumer, high, let's say, CO2 producer.
So when we talk about the technologies, again, is boiler manufacturer today, they are looking at some hybrid systems, like, for example, in near future, if the hydrogen is available, for example, in abundance, that you can use it for the steam generation.
Yes, I think, Anant, what you're referring to is hydrogen-ready boilers. So, yes, I think it's high time that we have to plan the future. And so let me start with some background. So let's say today, if hydrogen is available to a plant, can you burn it fully? The answer is no, because the existing infrastructure doesn't allow you to burn 100% hydrogen, because if you look at the energy density of hydrogen as compared to natural gas, it's 1/3, So you need higher volumes in terms of the heat input to the boiler. But of course, you can actually design a boiler to be hydrogen ready after 5 years, let's say when the gas is available. you have to do those modifications in terms of the design, in terms of calculating the right heating surface area to ensure that when it's time to shift from natural gas to hydrogen, you can do that and you can burn 100% hydrogen. As of today, it's possible to do a blend of both, where you have a mixture of 80% coming from natural gas and 20% coming from hydrogen. And by doing that itself, you can, when you do the numbers, you see that we can actually save almost 7% of the CO2 emission just by converting. But again, the challenge is, as Verma also mentioned in the earlier, the source of generating blue hydrogen or green hydrogen is very critical. As of today's, the processes that you use to generate blue hydrogen, green hydrogen are also very energy intensive. So we don't want to save the planet by burning hydrogen here, but also use natural gas to, produce electricity, to do electrolysis to, produce green hydrogen there. So of course, as time evolves, I think we'll see a lot of companies investing in technologies. By doing so, you can actually get these cleaner fuels at a cheaper cost so that the industries become ready to, use this at an affordable cost per some cube of hydrogen or any other clean source. Yeah.
I fully agree, Tony, because if you see the hydrogen cost across the globe, in Europe, in Middle East, in India or something, there is a huge differences. Now, huge difference definitely how you are fueling your electrolyzer. If you have to use renewable energy, in other part of the world, I am sure in some of the world, hydrogen cost is almost $10 to $12 per kg. In Middle East, it is around $4 to $5 per kg or something. Why? Because in Middle East, they are trying to leverage the solar energy and renewable energy or something. And because their natural gas is also cheaper, it makes sense. How do you mix natural gas and hydrogen? Instead of being 100% hydrogen, you leverage cheaper natural gas, you use renewable energy and make hydrogen and use for a different industry which is required or something. So somebody has to see it, the net benefit we are getting, and then only let's take 5 to 10 years when after 5 years there will be maturity, electrolysis cost will come down, battery cost will come down significantly so that you can store solar and wind energy when the time is required. So I'm sure we have to give some time to get this mature everything, and by 2030-35 we will get a better picture as far as hydrogen is concerned.
Indeed.
The awareness of sustainability through decarbonization is already there in the industry, correct? And the corporates are laying down their policies to achieve it in near future. And of course, whatever technologies, whatever efforts they can put in to decarbonize their steam plants, they are putting it and optimizing to get more economical and more efficient energy. So we can say that. So we are on the way to achieve that sustainability today. Of course, there are challenges like the return on the investment which is required is not friendly, in fact, in today's scenario. So still, industry is working toward it. The technology partners who are innovating or which are building up the machines, they're putting a major focus on sustainability as well. Means they have to build up the machines which are AI controlled now, which can also give you the reports which are favoring towards sustainability, that what you should do to maintain this power. So in a nutshell, that awareness of sustainability through decarbonization is there in the industry, and almost everybody is working towards it. Am I right?
So Anant, I partially differ to this also. I think generally their awareness is there across the industry, but how many customers are taking this seriously is the question, And I think that until and unless you either tax customers or you incentivize customers, these projects will not take any shape. It's my personal view. So, and this is where, governments can play a role, policies can play a role, saying that, look here, we are here to finance your capex cost. We are here to incentivize you, lower your carbon footprint. And by doing so, customers either look at earning money from the project or ensure that they don't pay money to the government because developing that project which is required to reduce your CO2. Yeah, so that's my opinion on this.
So that's what I say. Awareness is there throughout the industry, but corporates are laying down the policies. So general industry or normal small scale industry, they are more concerned about their daily energy bills and how they can cut short it. That's
The
it.
production is the criteria
Yeah,
above
it's
everything else.
Correct,
Yeah.
correct. But corporates, they have a sustainability vertical itself.
I mean, just to on the awareness side, I can share that Indorama, of course, works with B2C customers and B2B customers also. Wherever we are working with B2C customers, let's say Coke, Pepsi, or on the other side, Michelin, each one of them is coming back to us to know about our sustainability goals, our sustainability performance, and our sustainability roadmap going further. So I'm happy to share this, that we are all aligned on that. And we are also checking with our suppliers. And our suppliers are very big, much bigger than us. Let's say a SABIC or an ExxonMobil. So they are much bigger than us, but we are all aligned. So when it comes to the larger players, there is complete awareness and alignment. Of course, the smaller players get caught up in the middle, but slowly they are also building their systems. Carbon accounting, if they have 2 or 3 factories, they've slowly started installing, let's say, homemade software or just an Excel sheet or whatever, in trying to account for the carbon that they are emitting through their energy. So it's a process, and I think in the last 5 to 7 years, a lot has happened. And that's why I say in the next 5 years, I'm hoping that things will change. More regulations will come in. We have the CBAM in Europe, which will come in. We have the CSRD, which is a reporting framework, which will come in. These are all Europe-driven, and I would say that they are always the torch bearers when it comes to any kind of regulations to show the way. And that kind of spills over to Asia, and Asia then follows. So that's how the process goes. Yes, there is a lot of stress, a lot of pressure on the European industry, but they still at least come up with these ideas, they implement it, and the rest of the world follows.
So finally, we come to a conclusion again to this topic, saying that we all are committed to sustainability to achieve the decarbonization in the steam plants, because we are the experts in the steam in generation. In fact, the users, they always have a pressure, their customers, to become a sustainable organization and help the earth, the mother earth, to get rid of the major issue which today we are facing. So we can say that at least for Thailand, in the next 25 years, means by 2050, they are targeting net zero. Everybody's contribution will lead us to reach that goal in future. I would like to thank the all panel member here today for contributing towards this discussion, and must be yielding something fruitful out of this discussion in future. Thank you very much.
Thank you.
Thank you very much.